Hello, this is Mr. Agbamu Idonogrene. I'm here to teach mathematics on the topic latitude and longitude. And in today's class, I'm focusing on these objectives: to locate point on the surface of the earth, to calculate angle between 2 points on the surface of the earth, then to calculate the distance between 2 points on the surface of the earth. In our previous class, we did location of points on the surface of the earth, and we did calculations between 2 points on the surface of the earth. So our focus now is how to calculate the distance. Since you know how to calculate angle between 2 points, you know how to locate point on the surface of the earth. Then how do you get the distance now between 2 points? And remember this topic, latitude and longitude, when we are talking of 2 points, we are talking about the 2 points we are looking for the distance. They are either standing on a latitude or they are standing on a longitude. So take note of that. Just like your graph, when you are plotting your graph, you need the XY axis, and each point must stand on X coordinate and Y coordinate, and the second point must also stand on X coordinate and Y coordinate. So you need both of them to get the distance. The same thing with latitude and longitude. So the 2 points can either stand on a latitude or a longitude. Then from there you can now use your distance formula, which is length of an arc formula. You can see it here, theta over 360 times 2 pi r. So the only difference I did in the two formula is this. Let me show you well. The distance between 2 points on great circle, I use capital letter R, just to show you that is the radius of the earth we use for great circle, since the great circle is the largest circle the earth has. So we use capital R. Then the angle between 2 points on parallel of latitude. Latitude is also called small circle. So this circle is not as big as the great circle. So we use small letter r just to differentiate them. But you use both formulas. The two formulas are the same formulas. They are both length of an arc formula. So take note of that. So as we solve example, you will understand the two formulas very well. You see this place here, I say small letter r is the radius of parallel of latitude, and I put this is the formula we use to calculate small r. So you get the radius of the earth, the capital R, times it with cos alpha, and this alpha we have already treated it in our last class. You see alpha is the angle of latitude. You can see it here. So take note of this. If you go through our last class, you understand it very well. We did some calculations using this same formula, radius of parallel of latitude and radius of the earth. It's not a difficult one. If you understand that last class very well, this class will not be a difficult one for you. It will just flow very well. So let's go straight to this example. So this example is taken from WAEC question from 1991 WAEC number 24. It's an objective question. It's a simple one and a good one to start the examples on latitude and longitude. So if you look at this one very well, it says two towns P and Q are on 4 degree north and 40 degree west. So what this means is the point. So the first point is 4 degree north, which is the latitude, then 40 degree west, which is the longitude. Then it said and 4 degree north and 20 degree east respectively. So this respectively means P is the first point. The first point here is P, then Q is the second point. I've told you before, latitude and longitude is like graph. So these are the coordinates, like x and y axis. When they say when x is 4, y is 40, something like that, that's what we have here. So this place, when latitude is 4, longitude is Q. That's what we are saying. The same thing on the second point, Q, when latitude is 4 degree, longitude is 20 degree east. Let me demonstrate it here before I solve it. So in this demonstration, you can see what I have here. So this is how the earth looks like. This is a sphere. So you can see the north. I labeled this top as the north pole, and this is the south pole. You can see it. Then you can see the latitude. See, you can see how I'm moving it. This one is towards north, and you can see this is the angle, 39 degrees. You can see it. See how the angle is moving till to come down. Just watch this angle, this place to come down till you get to 0 degrees. You can see it now, it's 0 degrees. So the latitude is 0 degrees, so it's with the equator now. See, so this is the equator line now, 0 degrees. Then I have 2 points, I've labeled them already. This is point P, then this is point Q. See, they are standing on that latitude. So I designed it based on this example so that you see the picture of the example. Let me just rotate the head so that you can get the view very well. Then this is the prime meridian. This line is the prime meridian, the 0 degree line. So where prime meridian meets equator, so this is where they meet, so that is 0 degrees. So that's why you see the angle here showing 0 degrees. So this question says 4 degree north, so it will rise up. So 4 degree north will go up, but now I have 51, so let me leave it at 4 degree north. I just wanted to see this picture so that the question will be easy for you to understand. So when we talk of 4 degree north, you just come up 4 degrees north. So this is the angle, 4 degrees. This is 4. Let me put it here, 4 degrees. Then it said towards P is towards west at 40 degrees. So this is P. You can see the longitude of P. You can see it. So you move 40 degree west. So this is 40 degrees. You can see it here, 40 degrees. Then the Q is 20 degree east. You see how I'm sliding it, 20 degree east. So this is 20 degree. You can see there 20 degree. So if you want to view it very well so that it will look like a sphere, is to turn it and view it from the top. You see, now that I'm watching it from the top, let me remove this fall to this side, and this is the south pole. Let me take it to this. So this is towards east and west, then this is 20 degree east. Let me put it here so that you see it. Okay, so these are the two angles. So this is point P, then this is point Q. So this is the reference line, the 0 line. So this is 0 line. So P moves from 0 degree down to 40 degree west, and west, you know, is towards your left hand side. Then Q move from 0 degree down to the right towards east, which is 20 degrees. So all you need to do now is to get the angle between P and Q. So you can see the full angle between P and Q, which is 40 plus 20. So the angle is 60 degrees. So if you know this angle, you don't have any problem. Then the next thing we need to know is this radius. You can see the distance from P to the center, which is the same thing as the distance from Q to the center. You can all see it. So this is the radius. So this is the radius we use small letter r to signify, because it's a radius of parallel of latitude. So this is latitude. It's standing on the latitude. It's only the equator and other great circle, the longitude, they are the ones we use capital R. But since the 2 points P and Q, they are standing on this small circle, you can see it. So we use small letter r, which is capital R times cos alpha. And remember, the alpha is the latitude on which they are standing. So the latitude is 4 degrees. So the 2 points are standing on 4 degrees. That is all we are doing in this question. So let's go straight to the solution page. So all you do, if you want to show it on your paper, because you need to have a sketch that you submit. So you just have your circle. Get your circle first. Let me get my pencil to the thickness I want. Okay, this thickness is okay. Then go around, you draw your circle. Don't forget to locate your center. Okay, this is your center of your circle. And after getting your circle, the next thing we need to do, we need to get our lines of equator and lines of prime meridian. So the line that passes through the center. So just get a good sketch. Just make your work very neat. That is all we are doing in this topic. Draw your circle. take your ruler, get a neat straight line to represent the north and the south pole. Okay, so you label this place as the north pole, then you label here as the south. You just want to see this in your exam booklet. WAEC, they follow their marking scheme, so you can see. So you have your north and south pole. So I will use this my north and south pole line to represent my prime meridian. So this is my 0 degrees for prime meridian. Then I'll use my west and east line to represent my equator. So this is my 0 degrees. So all I need now is 4 degree north. So I will come towards north on top of this side and make an arc like this. So this one is representing 4 degree north. Just make it neat when you are drawing it. Then you label it 4 degree north. 4 degrees north. This is very, very important. Always label each line you have drawn in this topic. Then it says 40 degree west. Then this is your longitude. West and east represent longitude. Then after drawing this, make sure you label it. This is 40 degrees. 40 degrees west. Okay, then the other one is okay, where the 40 degrees west meets the 4 degree north, which is this point, that is point P. You label it as point P. So that is this point. Then the other point says 20 degree east. You draw your 20 degree east like this towards the right hand side. We are not drawing to scale, so the drawing may not look perfect compared to the one I showed you the other time, but just make it neat on paper so that when they are marking your work, they will know that you know what you are doing. So 20 degrees east. Alright, so that is this. So where 20 degree meet 4 degree north is this point, so that is point Q. So you label it as point Q. So you are done with this. Then if you wish to show the angle where they meet, you can label it something like this. Just draw hidden lines. Okay, so this is the angle. So this is the angle between P and Q. So this angle, that is what I try to show you in this place. And see it. So the angle between P and Q, when I did it like this the other time. So this is what I was trying to do. Then this is the line, this is the radius line. So you can see what I am doing. You can see what I showed you the other time. This hidden line from P to the center, from Q to the center. That is what I'm trying to do with these lines I have. So by the time you understand all this, you have no problem with the topic. So that is all with the diagram. When you have a diagram like this, you are through with the diagram. The next thing is use your formulas very well and do your calculation. So we need to get the angle. After getting the angle between them, we get the radius, then we can use our formula and calculate. So now let's go straight to the angle. So the angles now, so the angle between P and Q is okay, this one will give us we have checked it the other time. We said it's 40 plus 20, which is 40 plus 20. This one is going to be equals to 60 degrees. So 40 plus 20 will give us 60 degrees. So you settle that angle. And remember, this angle, we use a symbol for it. This is we are using theta to represent that angle. So this is the angle between P and Q, theta. Then you get that. Then the next thing we need is the small r, radius of parallel of latitude, which is small letter r will be equals to We said capital R cos alpha. So this, and alpha is the latitude on which P and Q are standing. See, they are standing on 4 degree north. So that will be the alpha. Then, without wasting time now, small r will be equals to, remember the question says give your answers in terms of pi and r. So we are not giving the value of capital R. So we don't use any value here. Just leave R as your answer, in part of your answer. So you have capital R times cos, the angle alpha now is the latitude, which is cos 4. So you need to get the value of cos 4, then multiply with R, that is all. Then you can substitute it into the distance formula. Then R will now be equals to, so what is cos 4? You can check with your calculator. Let me check here. So cos 4 degrees is equals to what now? Okay, it's giving us 0.997. Okay, let me take it to 4 decimal. 0.9976. 0.9976. So it will be 0.9976 capital R. So this is our radius of latitude. Now that radius of latitude is known, then the angle between P and Q is known. The next thing I need to do now is the distance between P and Q. If I use the small letter d to represent distance, equals to, we said theta over 360 degrees times 2 pi r. So this is the distance formula. So when you substitute into this formula, d is going to be equals to, theta is 60 degrees, you have your 60 over 360 degrees times 2 pi. Remember the question says leave your answer in terms of pi, so don't substitute anything, don't use 22/7. So just leave it like that, 2 pi. Then r, we found this value, which is 0. times 0.9976 capital R. The final answer now, we can do it directly. Let me just do it directly here. So all I have here is 60 divided by 360 times 2 times. Let me just solve it here and get our answer. You can use your calculator and do it directly. 60 divided by 360 times 2 times 0.9976. Just use your calculator and do it directly, you will get the answer. Oh, okay, this is not the right symbol I'm supposed to use here. Sorry. Let me use the actual symbol. Okay, so this is our answer, 0.33. So the final answer here is D is equals to 0.333, leaving pi and r as part of the answer, which is pi capital R. So we can leave it. So this is the answer, pi capital R. So this is the answer in terms of pi. That is the first example I have for you on this topic, latitude and longitude. Example 2, taken from WAEC 2000 number 13. It's a theory question. Let's study this example together. Okay, the question says 2 places X and Y, both on the equator, are on longitude 67 degree east and 123 degree east respectively. Okay, that means we have 2 points, X and Y. X is on this longitude, then Y is on this longitude 123 degree east, and both of them, they are standing on the equator. Okay, let me still demonstrate this before we do the solution. So this is my sphere now, representing the Earth. You can see it, the North Pole and the South Pole. You can see the polar axis at the center there. Okay, then you can see my prime meridian from north to south, which is the reference longitude. Then you can see my equator at the middle. So if I place it on using the front view, you can see something like this. You can see the north. You can see why I'm always doing it like this paper. And this is the equator. Then these 2 points are standing on the equator. Okay, let me leave it in this way so that we can see the 3 dimension very well. Okay, so we have 2 points, which is x and y, 2 places on the equator. Okay, so let's start. Okay, let me place this. Let me get my point. Okay, let's take this point. This is 1 point. This is another point. Okay, let me label them x and y. Just wanted to see it as a real object, get the meaning very well before we solve. Then this is point y. Let's rename it. Okay. Alright, and remember their longitude. So east is longitude. So let me put my longitude line. So this, and this. These are longitude. This, and this. Okay. Then you know they are also they are also coming from the center of the Earth. That is their radius to this point, from the center of the Earth to this point. Okay, so this is what we have. So this is what we have. Okay, I think you can see it very well. Let me move my south down. So this is point X. Let me put it here, point X. This point Y. Okay. So the question says 2 places X and Y both on equator are on longitude. So the first longitude is 67 degrees east. That means, which is X. You can see it. No, east is towards your right, which is this one. So let me put the angle so that we can see the angle very well. So this angle is, so I have okay, let me just label the 2 angles first. Okay. Okay. This is let me remove the alpha sign there. I need a lead value. Okay. Alright. Okay. So the first point X moves, let's see it again, 67 degrees east, then the other one is 127 degrees east. So this is point X. So if you start like this, 0 degrees, I think you can see the angle, 0 degrees. So X move towards east, 67, you can see the angle. Move towards east, which is towards the right hand side. See 65 to 67, so 7 degrees, that is point X, you can see it. Y point Y, see this point Y, that is this very angle, that is 0 now. So YY moves still on the equator, it moves, you see the way it's moving, it moved to 123. So this is Y, 123. If you view it, well, let me view it like this. Okay. If you view it, you will see that. Okay. See, this is X, this is Y. So this is the representation on 3-dimensional view. If I look at it from the top, so this is what I have from the top. 67, 0, to x, then from 0 to y, 123. So the angle we need now is this angle. If you can get this angle x and y, it will be easy for us. So all you need to do is from 0 to x is 67, then from 0 to y is 123. So you just subtract 123 minus 67, it will give you this angle. That is all we are doing. And you can see that this is an arc, so that's why we use length of an arc formula. It's not even a difficult question, it's a simple one, so it's not difficult. And what did the question say we should do? It said what is the distance between them on the equator, you see. So let's find the distance between x and y on the equator. So if you want to solve it now, you need to have your sketch. So let's just make a circle very fast. Get a circle. This is the first thing you do when you are answering this. This is your center. Then you get your ruler. Get your ruler very fast. Just make it neat. This is your center. Okay. Then this is all you need. Then you label your north, label your south, label your east, you label your west. Then you can just make a line like this to represent your equator. So the equator is also a latitude, so label it. Make sure you write it equator. Make sure you write it. This is the equator. You need to know what you are doing. Okay. So this is your equator. Take note. So let us know the angle 0 degrees. So this is your equator. Then on this equator you have the first one is 67 degrees east. So you draw your longitude. So something like this you do on paper, just make it neat. And make sure you label it 67 degrees. 67 degrees east. Then you have another one on the same east also. You go like this. This is what you put down on your paper, the one you submit to the examiner in your exam. Make sure you label it 123. Also towards east. So that is all. Then this is your center. And this is the first point x. Then this is the center to the second point y. Then this is y. So that is also, you need this angle here. This is the angle you are looking for. The angle between x and y. So we have already proved it. Since both of them are on the east side, it will be 123 minus 67. That is the angle from 0 to y is 123. Then from 0 to x is 67. So 123 minus 67, you get the angle between them. So this is the diagram you need to draw down on your paper. This diagram you are okay. Just make it fine and neat. Then let's go straight to the solution now. So now that you have seen the diagram, you know how to draw it. All we need first is angle. In this topic, we always find the angle first. Always calculate the angle first before you do any other thing. So angle. So angle between x and y is, so angle between x and y is 123 minus 67. So this one is going to give us what? So 123 minus 67. You have your 6, 5, that is 56. 123 minus 67. You have your 56. Okay, 56 degrees. So that is it. Okay, now that you have your angle, what next? Everything is given the formula. The 2 points are standing on great circle. Remember, equator is a great circle, so you are not using small letter r. Since equator is a great circle, just use your capital D. So capital D is the distance on great circle. I just use small d and capital D to differentiate them. So you have your theta over 360. Now we say theta, not q. Theta all over 360 times 2 pi r. So this is the formula for angles between great circles. Later now, 56 over 360 times 2 times 22 over 7 times 6,400. You can use your calculator and check it. You see that you will get the same answer. Let's put it in decimal. So this is the answer for distance between x and y, which is capital D, is equals to 6257.778 kilometer. So this is the first answer. So take note of this. So the distance between x and y is 6,257.778 kilometers. Since the question did not tell us to leave it in any decimal, so let's leave it to 3 decimal places. So that is the first answer. Use your calculator and check. I just did it fast because of time. So take note of that. Okay. So the second question says we should find what? So take note of this is capital R. Now I used small r before, but I've later changed it to capital letter R. So take note of this. So we are looking for distance between great circle, not small circle. So equator is a great circle, so you use capital R. Take note of this. So that's why we have this. Very, very important. Okay, so now let's see number 2. Say how far is x from the North Pole? So how far is x from the North Pole? That's number 2 now. So x from the North Pole, let's see our animation. So this is x. So you see x from the North Pole. So x and North Pole, they are on the great circle. All you need is the angle between them. I've already put the angle there, which is 90 degrees. You can see. You see the line that linked to the North Pole and the line that linked to x. You can see it now. They are all 90 degrees. So now that you know the angle between North Pole and x, you are okay. If you use your sketch, you can say this is x. So x to North Pole. So this is the distance they want us to find to this question. So you only need the angle between x and this North Pole line, which is 90 degrees. So the angle is 90 degrees, so we don't need to waste time. And since it's also on the parallel of, it's on the longitude, so it's capital D we are going to use, which is 90 divided by 360 degrees, then times 2 times 22 over 7 times radius, which is 6,400. That is all. So if you also solve it with your calculator very well, let's just do it directly. 360 times 2 times 22 over 7 times 6,400. So let's put it in decimal. So this is your answer. So So D is equals to 10,057.143 kilometer. So this is the answer of this question. So that is the solution of this question. Number 1, angle between x and y.